Hi, from previous video, we built feature engineering pipeline. We assume that the feature is loaded into the feature table hourly. Also, you might wonder why we need automated ML workflow. If let's say after you train the model and deploy your model into REST API, then after certain period later, you will identify that the data is different from previous. Then we need to retrain the model with the new data. To automate, to simplify this model training, you can create a model training pipeline. We set several tasks that is required to model training. Also today we are going to learn how to integrate MLflow within the Airflow task. Without further ado, let's get started. First, I'm going to create one tag. Import all the libraries, set default argument, define tag. At this time, we just leave schedule interval at once. Later, if model training pipeline run correctly, then we will set the schedule interval. Here you define series of tasks. You define the task dependencies. And also we need to import modules to execute all those Python callback functions. To do that, we inside a script we create model training. First, we create within the model training, we create all these modules. Then first, we go to the extract the py, go to preparation, and for the model training, model validation, and export model, export logic in export module. Go to register. We import all these modules here. Now all this callback function is ready. Import those libraries and operators, all these modules. Define your argument. Create a tag with name, model training soul, and schedule interval. Later we were going to change. For the first task, we are going to extract data from feature. We prepare data. We do the split the training and test set, and also splitting the x and y, the normalizations or some transformation to. And then the next task, there's the model training. So training the model, evaluate your model with all these performance metrics based on your types of model after you validate it. And then you are going to prepare your model to be pushed to registry. Last task, you push your model to model registry. So if we go to the first task in the extract, this logic is quite simple. You get the Postgres hook using the weather connection we defined earlier. We using the SQL query, select everything from feature delays table, try to get the data. After you got a result, you need to convert this datetime columns or other columns to string to push to the XCOM. That's why we are doing this step. Then we can use XCOM to push the data, which can be used in the following tasks. The next task is preparing data. If we go to the preparing data callback function here in the preparation.py, you're setting the random seed here. Within the function, we get the data from previous task, create data frame. After that, to transform the target variable with the log transformation. Also, we are using log 1p to prevent target variable to be negative. After that, We are going to train model with only one time series, which is city equal to Seoul, because in our data we have a full time series data based on 4 different xy coordinate. For the simplicity, we are only using the Seoul to train a model. So using only select the time series for Seoul. Then we set this timestamp as a datetime index. We converting to the datetime format, and then we after that we setting this timestamp to the index, and then after that we for is featured as a x, and then we set delivery hours log to be we assign to y, and then after that we using the scikit-learn's train test split function to split the train and test set each of x and y, and make sure the time series data we do not shuffle to preserve time dependency. Our data is ready to be trained the model. Then we need to send this full data frames to next task to train a model to send this data through the XCOM. We need to make sure that timestamps is to be string to send the data via XCOM. If not, the XCOM will generate the error. So that's why we need to do this. We send the data through XCOM to be used in the next task, which is the model training. So after we prepare the data, and if we go to train task, and then the callback function here, train the model. Here we try to get the all this 4 data from previous task, convert this to the data frame. Also, all this timestamp is now to be a datetime object, and then set as a datetime index here. Now you have a MLflow comes to play. Here you define MLflow tracking URI to log your all this metrics, model artifacts, all those things. First thing you need to do is setting a tracking URI. So I already set the environment variable in .env file. In environment variable, you already defined. After you followed intro here, localhost 5001. If you click the .env file, you need to set environment variable. This is the MLflow tracking URI in localhost. But once you deploy this into the server, then the server URI will be your MLflow tracking URI. So once you set MLflow tracking URI, you validate whether the tracking URI is set. You're using MLflow and set the tracking URI here, and then you set the experiment name, automated weather delivery delay prediction. So you can set based on your context. So after that, you define with MLflow start learn, and then within here you set all those parameters that is identified during the model development in hyperparameter tuning stage. I discover those are optimal hyperparameters. Then I'm using random forest regressor as our MVP model, and we provide these parameters to the random forest model. And after you define the model instance, then you're gonna train the model using the X train and Y train. After you train the model and you predict your prediction using the X test, and you're gonna get Y prediction log, because initially we transform data to with log transformation, and then the output also the data is already format as a log transformed. So we need to reverse back to original format using the numpy exponential 1, and then you got the Y prediction original, also the Y test as well. Sorry, you're gonna calculate root mean squared error with original scale of Y test and Y prediction. Then you're gonna get the root mean squared error. You're going to log all these parameters and artifact using MLflow for all these parameters that was trained the model, you're gonna log using log params. For the reference, your timestamp, minimum timestamp and maximum timestamp. Also your logging from xtrain, and from you're using your xtrain. For your RMSE metrics, you're gonna use log metric function from MLflow, log it. Also another one, I'm going to use a log dictionary columns that used for model training, and also that the feature importance. Lastly, we need to use log model to save artifact. Artifact means our models and all those packages that used to train the model. We are using the random forest model, so we are using the MLflow scikit-learn. So if you are not using the model from scikit-learn package, maybe you can use another one. Anyway, you're going to log your model here. We're gonna send the run ID of the experiment, also the root mean square error for the next task. After training done, you need another steps for model validation. If you go to the validation step, you will see first you need to pull your root mean squared error from previous task, also the run ID used for the training, and then we are setting the threshold value here. I roughly set the threshold value for 0.5, but this you need to change based on your business context, or you define the value makes sense to evaluate. In our logic, if the root mean squared error is higher than threshold value, which is we are making sure that model performance should be better than this value. If the error matrix does not is not better than this threshold, that we can determine that the model performance is not meet our requirement, so task failed, so we need to retrain the model, or we can adjust the threshold. So after we validated the model's performance metrics based on our preset threshold value, then we're gonna set the tracking URI and get the experiment name, which is the same as earlier. And then so after we validated that the model performance meet our requirement, then we can verify that the experiment run ID is exists. To do that, we using the MLflow client. Using this client, we get the experiment name, whether that this experiment name is exist in the model MLflow tracking server. And then after we got the experiment, we using the run ID we got from previous task, verify that the run ID is exist. Using the same run ID from previous task, we log metrics that additionally log that the validation is passed. So this is the validation logic. After we validate the model's performance that meet our requirement, then we can go to next task called export. What we do in here is that we get the run ID that was used for model training, and then with this run ID, and then also getting tracking URI from .env, and then we set the tracking URI, and then we generate and validate model URI for model registration. Preparing this model URI is purpose our task. So using this one runs, and using our run ID that was used for model training and random forest model, we prepare this model URI logic, and we get the MLflow client. This logic, whether we check the model artifact is exist or not. During the model training, we log the model, and then after we log the model, that model is logged in the model artifact store. So we need to make sure that the model artifact is exist for pushing our model, for register our model to model registry. So if we cannot find the model artifact, cannot register our model to model registry, so we need to validate whether our model artifact exists or not. And then after that, we're gonna load our model using that model URI here, we define here. If we cannot load model using this model URI, also if this model is not the instance of the random forest regressor, then we need to raise the error that model is not instance of the random forest. So we need to verify the model format here. Lastly, we need to export our metadata using the MLflow start run with using the same run ID, and we need to log our the parameters, which is the timestamp for the export, which is the current timestamp here, and also we log the parameter that is model URI we just prepared here and verified here. We log the status that artifact status verified XCOM to push our model URI for registration. So after that, we go to last step called push to model registry. So if you go to the model registry, if you go inside of this function, and first you will pull the model URI from previous task, and also you get the run ID from model training task. So we get model URI and run ID. So we need to verify that whether one of the two data not exists, we need to raise the error. We get MLflow tracking URI from environment variable, and then we set the MLflow tracking URI. Before we register model, we need to have a model name. We define the static value, the delivery delay model. So register here model, register model to model registry using this one, MLflow register model, using the model URI and model name we just defined here. After that, we using the MLflow client. There is a logic deleting existing staging alias. We get the search model version using MLflow client. That model name here. We get every version here, and then within the list we get versions, and also we identify that models alias is staging. If we identify that any model versions with alias of staging, then we delete the model alias, the name is staging. And then after we delete the staging alias, then using the current model name here and using the current model version, just we registered and we set alias to the staging. So make sure we are register the model with the staging alias. And also in this logic, we're going to set the model version tag. Tag is different from alias, and using the key stage, and we set the value to staging for your reference. After registered, and you need to log the parameters using the same run ID that was used for the model training, and you set the registered model name here and model version. After your registration, you got the model version, and then your model alias say staging, and then after that you push your model version to XCOM. Yeah, that's it. That is the logic of the model training pipeline, and you will see that the model lifecycle is managed by the MLflow. Those model named scikit-learn does not exist. So in this case, we need to install our scikit-learn package to our Airflow web server. So I don't see scikit-learn packages in requirement.txt. Update my requirement.txt file. You need to shut down your containers, and you need to build the images again, because the Airflow web server used the containers are already built. Since we updated our requirements.txt file, Airflow's web server's Docker image already built. So we need to remove the image and rebuild to ensure the scikit-learn package is installed. To do that, we can After we revealed our Docker images, you can see that the error in the this part disappeared. That is, we installed scikit-learn within the Airflow web server. So now I identify the error from previous feature engineering pipeline. That is, if you go to the code and the first task, that is wait for the master, you need to uh, the specify the deck ID that is listening to. The ID is different, so we need to change, and also make sure also we need to check whether the last task ID is mark processed. If you go to here, the last task is mark processed. It's the same one, but I guess seems we have a lot of error. I'm going to fix the feature engineering pipeline first. At the data here, feature engineering hourly tag here. In here, wait for master task. Make sure we change to external tag ID should be the same as the task, the collecting data to master tables. That is name should be same as deck here. Also identify one issue that deck fails due to the timeout. So we can set this one and PSA fetch weather data. You can set timeout longer. You fix the error of the feature engineering pipeline hourly. Now we solve the package error. For this deck, we're gonna go back to the Airflow UI. Yeah, since we don't have enough data in pipeline, I'm going to show our production pipeline here. If we go to this pipeline, is identical that I showed you before. I didn't really set a schedule interval yet, so I'm gonna manually trigger our pipeline to demonstrate for your reference. This run will run correctly because the weather data is already collected in our pipeline, and then many features also loaded in feature table. So to run the model, it shouldn't be a problem. So let's trigger our tag here. Yeah, so our automated ML workflow done. If you go to MLflow URI here, then you will see the automated weather delivery delay prediction. So the experiment name, and then we can see the run name here that is created 1 minute ago. I just run the pipeline. If you go inside, you can see all this information. You can see run ID that we logged using model training, and the timestamp, minimum and maximum. Also we logged during the model training. Also model URI that was we also logged. Also model alias. And if you go to model metrics, you can see the root mean squared error. We logged the metrics during the model training. So you can go to artifact tab. You can see, so you can identify that all this information, the conda virtual environment, and this is the model. You can see the Python environment. Also you can see the requirement, the txt. So this one is it will use for model packaging, and also we log the feature importance in during the model training. So this one is in logged in the MLflow the tracking URI. So if you go to AWS S3, this one is S3 bucket artifact store when we are created, but since we are referring our existing model, we can go to the my existing artifact store. So if you go to ml run, and then if we go to the overview, the experiment ID is 3. So if we go to 3, the run ID, we find, if you paste it, and then we can see the run ID here. Within the directory, we can see the artifact. The artifact directory, we can see the random forest model. And here we can see all those artifacts from here. In the random forest model, you can see the actual file is stored in here. Conda YAML and ML models, and most important one is this one, model. Also during the export and during the push model, the last task, we registered model with staging. We registered model to model registry with the staging alias. With model version 30, we set the alias as a staging, also the tag as a stage with value of staging. This is the way you are managing your model version. During the demonstration, I got the issue that our tutorial deck does not have enough data, so I cannot really demonstrate the model training. Instead, I show you my existing pipeline. From here, you can the automate model training process. You can schedule every day or every hour. It's up to your business context. This will gives you a lot of freedom that to hatching your data drift issue. Also integrating MLflow, you will have a lot of control to managing your model lifecycle. This is end of our video. If you like the video, please subscribe, like, wait for the next video.